those partials and then conclude here. So for the d-test, we have to solve the equation f of x, fx0. So notice that this is not f of x. This is f and suffix x. Okay, so these are two different things. This is a function, and this is the partial of f with respect to x. So first, we are going to determine fx and fy, not f of x or f of y. Fx, fy. We set them equal to each other, set them equal to 0, and create a system. From this system, we get a point or points, and then we determine d, that is fxx, the second partial xx, evaluated at a comma b, this point or points, multiplied by fyy at a comma b, and minus fxy at a comma b, but squared. So we create a system, we find solutions. If there are no solutions, there are no max-min. There is no max-min. So if we have solution or solutions, then we determine the d. The d is the second partial evaluated at AB times the second partial yy evaluated at B, then minus the mixed fxy evaluated at a comma b squared. And now there are three options here, basically. If d is greater than 0 and fxx at a comma b is less than 0, then a comma b is a relative max. If xxx at a comma b is greater than 0, then a comma b is a relative min. If d, so this is number 1, this is number 2. If d is less than 0, none, no max min. And number 3, if d equals 0, d-test not applicable. Okay? So that's the d-test. So now first let's practice finding these derivatives. So one more time. We determine for the function, if we're asked to find max-min, we determine fx, fy, we set them equal to 0, and we determine this point after solving this system. Then, with this point, we plug it in fxx, we get a number. We plug it into yy, fyy, we get a number. We plug it into fxy, we get a number, and we square it. We determine this number. Number times number minus a number squared. If d is positive, then we simply look at this number and see if it's negative, then this is a relative max. We look at this number, if it's positive, it's a relative min. If this number is negative, there are no max min. If this number is 0, the d-test is not applicable. Okay, so now this is it. Okay, so first let's look at so we are given a lot of, so let's choose from here that any function. Find the 4 second order partial derivatives. What 4? fxx, fyy, fxy, and fyx. fxx, fxy, fyx, and fyy. So any function you'd like to pick, and let's determine those 4. Of course, we have to find fx first and fy. Do I pick them?
Professor, I don't see nothing on your screen.
Nothing on the screen. Oh, I thought that I'm the only one who sees nothing.
Really? Am I logged out? Is this better?
Yeah,
That's
that's
working.
yeah.
Okay,
Yep.
sorry about that. So we want to find, of course, fx and fy, because if we don't find the first partial derivatives, we cannot determine the second partial derivatives, right? So let's choose a function.
Maybe 31.
Okay, 31, it's a simple situation. Let's work on something slightly more difficult.
Can we do 30?
30, very good. So let's look at 30. So this is fxy, which is x to the 5th, y to the 4th, plus x to the 3rd, y squared. Remember, if fxy does not equal fyx, then we said, oops, something is terribly wrong. Okay, so we have to find fx. You don't have to use this notation, but the correct notation, I mean, they're both correct. This is the correct, right? So the partial of f with respect to x, which means f has more than one variable in it. So obviously we're keeping y fixed. We are only differentiating with respect to x. So can anyone differentiate this with respect to x?
5x to the 4th.
I have to copy it, right? Plus, can anyone, because it's a product, right? I can drop it. Can anyone differentiate this with respect to x?
3x squared plus, or well, y squared.
Perfect. So this is done. So now let's find fxx. Coming back here, we are differentiating this term with respect to x.
20x to the 3rd. And then y to the 4th.
Perfect. Plus, we are differentiating this with respect to x. Everything else kept fixed.
6x y squared.
Yes. Perfect. Now we can also find fxy because we already have fx. Coming back, we need to differentiate this term with respect to y.
Five x 4y to the 3rd.
We are differentiating with respect to y.
20x to the 4th, y to the 3rd.
Very good. Is that clear, everyone? We're differentiating this with respect to y. This is fixed, this is fixed.
Plus 6x squared y.
That's it. Perfect. Now fy. Back here, we're differentiating with respect to y. This is fixed. Don't even look at it, but you have to copy it.
X to the 5th, y 30.
Perfect. Plus, we're differentiating with respect to y. X cubed is fixed.
2x cubed y.
Very good. Awesome. Now we want fyy. So we're differentiating this term with respect to y. These are fixed. Don't look at them. Don't try to differentiate them, but you have to keep them.
It's 12x to the 5th, y to the...
Perfect. Plus, we're differentiating this with respect to y.
2x cubed.
That's it. Finally, the last one, fyx. fyx. If this is not identical with this, then we have to go back to the drawing board. We hope that's not the case. So we have fy, and now we are differentiating with respect to x. Can anyone differentiate this with respect to x? These are fixed.
Is it
20x to the 4 y cubed 2.
Plus. Can anyone differentiate this with respect to x? 2 and y are fixed.
6x squared y.
No need to go back. Good. I would like to show one example with a d-test, and then we'll make a decision on Wednesday on how to proceed. I really wanted to have a little bit more time, but I can't rush, and I have to explain things. 576. So let's take a look at one d-test to find max min. Okay, here it is. Good. So let's choose a problem from here and identify whether it has a max or a min and go through the d-test. I promise to stop. I don't know where my phone is, but you'll stop me. Please stop me because I don't know where my phone is. So
Okay, which number 7?
yes, the lucky 7. Let's do that. So 7 on 576. And this is f of x comma y equals x squared plus 2xy plus 2y squared minus 6y and plus 2. X squared plus 2xy, I copied correctly, plus 2y squared minus 6. Okay, perfect. So, of course, we have to find fx and fy. Oops. So we differentiate this with respect to x.
2x.
Perfect. We differentiate this with respect to x.
2y.
Perfect. We differentiate this with respect to x.
It's just 2y to this.
With respect to x.
0.
Yes.
0.
With respect to x.
0.
With respect to x. Perfect. Okay. Now, fy. This with respect to y.
0.
Perfect. This with respect to y.
2y.
With respect to y.
2x.
Perfect. This with respect to y.
4y.
Excellent. This with respect to y.
Minus 6.
Perfect. This with respect to y.
0.
Perfect. This is our system. 2x plus 2y equals 0. And 2x plus 4y, I move 6 to the other side. So we try to simplify this and get an ordered pair, right? So I'd simplify by 2, and I get x plus y equals 0. Or I can simply eliminate one of the variables. So let's do that. Doesn't matter. So we multiply the first by -1, and then we get -2x minus 2y equals 0, and 2x plus 4y equals 6. X is gone. 2y equals 6 means y equals 3. Let's plug in 3 and determine x. And that's our point. We didn't need to simplify anything. I always try to simplify it, but in this case, there was no need. Okay, so if y is 3, so 2x plus 6 equals 0, or 2x equals -6, or x equals -3. So our point in discussion, that a comma b that we just mentioned in the d-test, is -3, 3. So I'm going back here. So in our example, this point, after we solved this system, we got -3, 3. So now we have to plug in -3, 3 in fxx, -3, 3 in fyy, and -3, 3 in fxy. We did not determine these yet. We only determined these 2. So we have to determine these 3 now. And then plug in that point. So fxx, let's differentiate this term with respect to x.
2.
2. Let's differentiate this with respect to x.
0.
Excellent. So now fyy. So let's differentiate this with respect to y.
0.
Perfect. Let's differentiate this with respect to y.
4.
Perfect. Let's differentiate this with respect to y.
0.
Perfect. Last one we need is fxy. Fx, now I differentiate with respect to y. Let's differentiate this with respect to y.
0.
Perfect. Let's differentiate this with respect to y.
2.
2. Awesome. So now the d test. We have to find d first. I wanted to plug in here, but there is nothing to plug in. So it's 2 times. I wanted to plug this in here, but there is nothing. It's 4 minus. I wanted to plug this point in here. There is nothing. I have to write 2 squared. Again, fxx at this point, it's a constant, 2. Fyy at this point, it's a constant, 4. Fxy doesn't always happen. I will have to plug in, but there is nothing. So 2 squared. So now let's see. 8 minus 4 is 4. So this is a positive number. This is a positive number. D is positive and fxx is positive. So what do we know immediately about negative 3, 3?
So that's our minimum.
The relative minimum. That's it. That's how the d test works.